Namaste, Hamisha Khush Raho Betiya. My name is Manisha Singh. Today I am teaching you sedimentation and settling in unit operation subject. Now let's start with the sedimentation. First of all, after the source water has been coagulated and flocculated, it is ready for the sedimentation. Okay, so there is from the lake there is an intake of water from in a pipe. Then there is a preliminary treatment by the protection bar screen and the traveling water screen. After that, the water is moved to the low lift pump well, by which there is a pre-chlorination step, and then there is a chemical coagulants are added, so that coagulation and flocculation step is take place. Then there is a sedimentation basin, and after that there is a sand filtration. Then what is the objective of sedimentation? It is to separate solids from liquids using the force of gravity. In sedimentation, only suspended solids are removed. Sedimentation is used in water and wastewater treatment plants. Applications in water treatment is settling of coagulated and flocculated waters prior to filtration, settling of coagulated and flocculated waters in a softening plant, settling of treated waters in an iron and manganese removal plant. Then applications in wastewater treatment, that is grit removal, suspended solids removal in primary clarifier, then biological floc removal in activated sludge. Then there is a sedimentation basins. Shapes are circular, rectangular, and square. And sizes are for circular basins, it is 15 to 300 feet in diameter and 6 to 16 feet in depth. Then typical sizes are 35 to 150 feet and 10 to 14 feet. Square is 35 to 200 feet and 6 to 19 feet. Rectangular, it depends on sludge removal mechanism, and there is a free board that is 1 to 1.25 feet for circular and square tanks. Then settling of particles from suspension, it depends upon the characteristics of the particles and concentration of the particles in the suspension. There is for characteristics of the particle, it is discrete particles whose size, shape, and specific gravity do not change with time. And then flocculating particles, like particles whose surface properties are such that they aggregate upon contact and thus changing in size, shape, and perhaps specific gravity with each contact. Then concentration of particles in suspension. Dilute suspensions are suspension in which the concentration of particles is not sufficient to cause significant displacement of water as they settle, or in which the particles will not be close enough for velocity field interference to occur. Then concentrated suspensions in which the concentration of particles is too great to meet the conditions mentioned for dilute suspensions. For discrete particle settling of discrete particles in dilute suspension, particles have no tendency to flocculate and they settle as individual entities, and there is no significant interaction with the neighboring particles. Example are removal of grit and sand in wastewater treatment. Then flocculent settling of flocculent particles in dilute suspensions as particle settle and coalescence with each other particle. The size of the particles and their settling velocity increases. Example is removal of SS in primary sedimentation tanks of wastewater treatment plant. Then settling of chemically coagulated water. Type 3 is hindered settling or zone settling. Settling of intermediate concentration of flocculent particles. Particles are so close together that interparticle forces are able to hold them in fixed positions relative to each other, and the mass of particles settles as a zone at a constant velocity. Example is biological floc removal in secondary settling basins in WWTP. Then compression settling is the type 4 settling, and settling of particles that are of such a high concentration that the particles touch each other, and settling can occur only by compression, which takes place from weight of the particles. Then examples occurs in the bottom of deep secondary clarifiers in sludge thickening facilities. Sedimentation tanks can be divided into the 4 different functional groups. First one is the inlet zone, then second is settling zone, third is sludge zone, and fourth is outlet zone. In the inlet zone, it should disseminate influent energy and distribute the flow and mitigate the density currents and minimize the sludge blanket disturbance. Inlet structures are designed to uniformly distribute the influent suspension over the cross section of the settling zone. For rectangular basins, full width inlet channels and effective spreading of flow introduce a vertical velocity component into sludge happen that may resuspend sludge. Inlet channels with submerged orifices for sedimentation tank followed by flocculation. Width of the flocculation basin minus width of the settling tank and depth of the inlet channel equal to depth of the flocculator basin. Pipe connection between flocculation unit and sedimentation. Low velocity in pipe is due to the settling of floc. High velocity of pipe is breakage of the floc. Then permissible flow velocity to maintain the floc suspension is 0.15 to 0.6 meter per second. If sedimentation tank does not adjoin a flocculator, inlet channels with submerged orifices do not extend down the full depth of the tank. For circular tanks radial flow and it achieve a radial flow pattern influent is introduced in the center of the tank or around the periphery of the tank. Central feed is water enters a circular well designed to distribute the flow equally in all directions. D of feed well is 15 to 20% of the tank diameter. Depth is 1 to 2.5 meter. Velocity through the orifices on feed well is 0.075 to 0.15 meter per second. Entrance pipe is the suspended from bridge or encased in concrete beneath the tank floor. Then settling zone is, it depends on the following design parameters, that is settling characteristics of the suspended matter, and surface loading is overflow rate, width or length ratio or diameter, detention time. Then sludge zone, rectangular tanks, the bottom is slightly sloped to facilitate sludge scraping. A pair of endless conveyor chains, bridge type mechanism, continuously pulls the settled material into a sludge hopper where it is pumped out periodically. Motion of scraper is momentarily resuspend lighter particles a few centimeters above the scraper blades, and excessive horizontal velocity for the case of rectangular basins move these materials towards outlet zone. To prevent this, horizontal velocity is 9 meter per hour for light flocculent suspensions and 36 meter per hour for heavier discrete suspensions. Then bridge type mechanism is travels up and down the tank. One or more scraper blades are suspended from the bridge. Circular tanks, the bottom of the tank is sloped to form an inverted cone and the sludge is scraped to a relatively small hopper located near the center of the tank. Velocity or scraper is important. Then very high velocity is resuspension of settled particles, and traveling bridge with sludge suction headers and pumps, not very good. Then outlet zone, where channels are used, large wire loading, resuspension of particles settled near to effluent launders. Then effluent weirs are placed as far from the inlet as possible. To increase the weir length is decrease weir loading, and double-sided weirs can be used. Then typical wires are 90-degree volt notch metal plates bolted onto the effluent collection through and may be placed at the opposite end of the rectangular basins through the entire width of the tank and through the length of the tank. If the wire loading causes the required wire length to be greater than tank width, the channel may be extended to a length of 1/3 the basin length or the Reynolds. Around the perimeter of the center, feed circular tanks at the center of the peripheral, feed circular tanks. Hope you all are satisfied with this session. This session is powered by Digital Version 2.0 Jyoti Vidyapeeth Women's University, Jaipur. If you have any query, please mention it in a comment box. I will resolve them whenever we have a live session. Thank you so much for watching this video.